Hello, my name is Gino, and I'm going to be your CA for this episode of ChemBuddy dealing with proportions, accuracy, precision, and errors. First, let's look at the two types of proportions you will see in chemistry. These are direct and inverse proportions. Direct proportions are where you have a quotient of two variables, or one variable divided by another variable. The graph of direct proportion is a straight line. An example of direct proportion is density, where mass is divided by volume. Inverse proportions are where you have the product of two variables, or one variable multiplied by another. The graph of inverse proportion is a hyperbola. An example of an inverse proportion is the distance formula, where rate is multiplied by time. These variables will be your data, whatever it may be. A lot of data in chemistry can be put into proportions, like temperature, pressure, volume, and number of moles. Also, proportions will sometimes be set equal to the value k, which represents constant. K is really just a placeholder though, and is not really important. The next big thing we need to look at is the difference between accuracy and precision. In regular speech, accuracy and precision are considered synonyms that can be interchanged. This is not the case in chemistry though. Accuracy and precision mean two entirely different things when we use them in chemistry, and you cannot mix them up. Accuracy is defined as the closeness of a measurement to the accepted value. It can also be thought of as how correct your measurements were. Precision is defined as the closeness of a set of measurements to the same quantity and are made in the same way. Precision can also be thought of as how repeatable your measurements were, or the consistency of your measurements. We measure accuracy using the percent error calculation. The equation we use is as such. Percent error equals the absolute value of the accepted value minus the experimental value divided by the accepted value and multiplied by 100. The accepted value is the right value you should have received from your measurements. The experimental value is what you actually received as your measurements. When taking measurements, you also need to keep in mind that types of errors that may occur that will skew your results. There are two major types of errors that can alter your results. First are systematic errors. These reduce your measurements' accuracy and are usually due to your instrument's failure or incorrect procedure. Second are random errors or indeterminate errors. These reduce your measurements' precision and can also be called human error, where the instrument's procedure were correct, but the person performing them made a mistake. Now, let's look at three examples to bring home your understanding of accuracy, precision, and errors. First, let's look at this target. The darts all hit the target in the same area, but they are not near the center of the target. This is an example of good precision, as all the darts are near one another, but bad accuracy, as the darts are not near the center of the target. If we relate this to errors in measurements, this would be most likely due to systematic errors. Next, we have this target. Here, the darts are all near one another again, but this time they are much closer to the center of the target. Now, we have good accuracy and good precision, with no errors. Last, we have this target. The darts are spread out across the target, and not many are near the center. Here is a case of poor accuracy, as no darts are near the target's center, and poor precision, as the darts are not close together. This result could be due to random errors, hurting the precision of this measurement. And that is everything you need to know about proportions, accuracy, precision, and errors. Thank you for watching this video and choosing ChemBuddy as your teaching assistant. And please come back and watch more of what our channel has to offer. For my fellow CAs, Chris and Emil, we wish you the best in studying and hope you enjoyed this video.